Welcome to The Explainer. Today we're diving into something that sounds like it's straight out of a sci-fi novel, but, well, it's actually happening. We're talking about the incredible idea of beaming limitless solar power down to Earth from space.
So, to really wrap our heads around this, let's start with a really simple question. Think about it. What if solar panels could work at night? What if solar power's single biggest weakness, the fact that the sun sets every single day, what if we could just get rid of that problem entirely?
Okay, so what you're seeing here is really the problem and the solution, side by side. On the one hand, you've got our current reality, right? Solar farms on the ground, totally at the mercy of daylight and good weather. And on the other hand, you have this incredible vision. Solar panels up in orbit, just soaking up constant, uninterrupted sunlight. We're talking clean energy 24/7.
Right. The sun never sets. And look, this isn't just some tiny little improvement we're talking about. The idea of capturing the sun's energy from orbit? Well, it could be a complete game changer for renewables. So let's break down exactly why.
Get ready for this number: 13 times. That's right, a single solar panel in space can generate 13 times more energy than the very same panel sitting here on Earth. And you might be asking, why such a massive difference? Well, think about it. Up in orbit, there's no night. There are no clouds. And you don't have our atmosphere getting in the way, scattering and absorbing all those precious high-energy photons. It's just a pure, constant, direct fire hose of solar power.
And when you start thinking about the potential uses, it's just incredible. We're talking about a source of clean electricity that's so reliable, so constant, it could seriously go toe-to-toe with a nuclear power plant. Imagine beaming energy to remote villages that have never had power lines. Or, think bigger. We could even power future bases on Mars. Seriously, the sky is not the limit here.
Okay, so from sci-fi to reality. This whole idea of space solar power, it's actually been kicked around for decades. But it's only right now that it's becoming something we can actually do. And Japan is really leading the charge with a groundbreaking project that's designed to prove, once and for all, that this can work in the real world.
And man, the journey to get here has been a long one. This whole concept was first dreamed up by a NASA engineer named Peter Glaser way back in 1968. But for decades, it was just impossible. The cost of launching stuff into space was just astronomical. But now we have absolute game changers like SpaceX and the reusable rockets, and that has changed everything. A crucial test mission is finally on the books for 2025.
So what is this mission? It's called Ohisama, which is just the Japanese word for the sun. Pretty fitting, right? So the plan is to launch this 180-kilogram satellite, that's about 400 pounds, into low Earth orbit, around 400 kilometers up. Now let's be clear, the goal here isn't to power a whole city just yet. It's all about proving the concept. It's that critical first step.
And this quote from Koichi Ayagi, who's an advisor on the project, really puts it all into perspective. He says, "It will be a small satellite that will transmit about 1 kilowatt of power from an altitude of 400 kilometers. So yeah, they're starting small. 1 kilowatt? What is that? That's barely enough to run your dishwasher for maybe an hour. But see, the goal right now isn't about generating massive amounts of power. It's about proving that you can beam energy from a fast-moving satellite down to one specific spot on Earth. That's the real test."
Okay, so this brings us to the really fascinating question, right? The how it actually works part. How on Earth do you get energy from a satellite that's zipping through space at 28,000 kilometers an hour and send it down to a tiny, specific spot on the ground? Let's get into it. Well, it all breaks down into 4 main steps. First up, pretty simple. The satellite's solar panels collect the sunlight. Step 2, that sunlight gets converted into electricity. Standard stuff. But then, step 3, and this is where the magic really happens. That electricity gets converted into microwaves. And finally, step 4, those microwaves are beamed right down to a ground station here on Earth.
So what's waiting on the ground to catch those microwaves? It's a special piece of tech called a rectenna. And the easiest way to think about it is like a microwave oven, but in reverse. You know how your oven uses electricity to create microwaves to heat your food? Well, a rectenna catches those microwaves from space and turns them back into usable DC electricity. It's pretty genius. For the Ohisama Project, the receiving station is actually going to be a whole array of these things spread out over a 600 square meter area.
If you really want to boil it all down, this is the best way to picture it. Just think of it like a super precise, long-distance wireless charger, but for the entire planet. We're not talking about sending some scary lightning bolt down from space. No, not at all. It's a focused beam of microwaves wirelessly sending power from point A to point B.
It's exactly like your wireless phone charger, just, on a slightly bigger scale.
All right, so the promise versus the problems. It's time for a little reality check. Because of course, an idea this big, this revolutionary, it's going to come with some equally massive challenges. The potential is absolutely incredible, but we have to be honest about the practical and, well, the economic hurdles.
And the biggest hurdle, by a long shot, is the cost. Just look at this. A recent NASA report estimated that power from space solar could cost something like 61 cents per kilowatt hour. Now, to put that into perspective for you, the solar or wind power we generate here on Earth, that costs about 5 cents. I mean, that's not just a little more expensive. It's the difference between paying a few cents to run your dishwasher and paying for a fancy latte every single time you turn it on. That massive price gap is without a doubt the single biggest obstacle right now.
And it's not just the sticker shock. There's some other really big engineering puzzles to solve too. For one, think about the greenhouse gas emissions from all the rocket launches you'd need just to build a single, large-scale power station in orbit. And then there's that mind-boggling precision challenge we talked about, trying to keep an energy beam perfectly locked onto a receiver from a satellite that's tearing through space. It's a huge challenge.
But okay, let's talk about the question that probably popped into your head a few minutes ago, because it's always one of the first things people ask. And for good reason. Is this whole thing safe? I mean, are we talking about a giant microwave beam from space that could be dangerous for airplanes or birds or even people on the ground?
Well, the short answer, according to the people developing this technology, is a clear no. Here's why. The power is spread out over a really large area, which means the intensity of the beam is actually very low. So you can get the image of a concentrated death ray from a sci-fi movie right out of your head. It's designed to be completely safe for any wildlife or aircraft that might happen to pass through it, and it can travel through our atmosphere with almost no loss of power.
So, is this all leading to a new kind of global space race? Because despite all these challenges, Japan is definitely not in this alone. Not by a long shot. What we're actually seeing here is the start of a huge global push to make space-based solar a real thing.
So who else is in the race? Well, you've got several major players investing a lot of money into this. Over in the US, both the Naval Research Lab and Caltech have already run some successful experiments. In the UK, a company called Space Solar is developing its own satellite, the Cassiopeia. And of course, the European Space Agency is actively working on the technology too. It really is a full-blown international effort.
And this is exactly why there's still so much optimism around the idea. The problems we're facing today, those are basically the targets for tomorrow's engineers. Think about it. Advances in miniaturized electronics will dramatically cut down on launch costs. Smarter, more advanced beam steering tech will solve that tricky accuracy problem. The technology is moving forward really fast, and that huge viability gap we talked about, it's starting to close.
And that leaves us with one final, really big thought. If projects like Japan's Ohisama actually work, and if we can overcome those huge economic and technical hurdles, could we be witnessing the dawn of our planet's very first global power grid? Imagine a network that delivers clean, constant, renewable energy to literally any point on the globe, day or night. It's a future that honestly is starting to feel less and less like science fiction.